Do you know how high fine particle concentrations in subway stations are? Well, according to studies, they are 1.5 to up to 5 times higher than normal atmospheric concentrations. That's too high, isn't it? This is why we need to take more proactive and effective measures to protect subway users from fine particulate matter. Experts also stress the need to set standards for mold and other airborne bacteria and for total volatile organic compound concentrations. We all know air quality is important, but public awareness of its importance is higher than ever amidst the devastating COVID-19 pandemic. Multi-use facilities are especially susceptible as they can easily become home to bacteria and viruses if their air quality is not properly managed. But how do we effectively manage air quality in subway stations? Let me introduce a new and innovative air purification technology using the electrostatic spray method developed by a research team led by Dr. Jong-won Choi from the EMS lab of Korea Institute of Energy Research. Dr. Choi's research team has developed a next-generation air purification technology using electrostatic spraying that can reduce fine particulate matter, airborne bacteria, and VOCs at the same time through application of high-voltage electricity to water. This technology has already been demonstrated in a Seoul metro station with successful results and has been attracting considerable attention. Dr. Jong-won Choi made himself available to answer some of our questions.
This device right here is the Electrostatic Spray Air Purifier, or Ultra Air Purifier for short. Dr. Choi,
Yeah.
how does this work?
You know, water, I think, is still one of the most interesting material in the earth. In general, when water is reduced to small droplets between 5 and 20 micrometers, its surface spontaneously divides into hydrogen and hydroxide ions. When these small water droplets are placed in a high electric field environment of several kilovolts per centimeters formed between the needle and the electrode, the hydroxide ions on the surface convert into hydroxyl radicals, while at the same time two hydroxyl radicals combine each other to form hydrogen peroxide, which is one of the most strong disinfectants. At the moment, some oxygen molecules in the air passing around the nozzle are probably oxidized to make ozone by coronal discharge. While passing through the electric field and at the same time are dissolved in the water droplets, creating ozonic water, which is also one of the strong oxidizer or sterilizer.
I see. So it's the hydrogen peroxide and the ozone water that kill the bacteria and the viruses that are suspended in the indoor air.
Correct. They also have the effect of reducing odor. Moreover, VOCs such as toluene, acetaldehyde decompose into carbon dioxide and water in that process.
It's surprising that the water that we drink every single day can do all of that without the need of any additives. So, Dr. Choi,
Yeah.
can you show us how it works in this lab?
Okay, let's have a look. I have filled this syringe with water and I'm pressing the plunger slowly. As you can see, as I push the plunger through the needle here, due to its surface tensions, the water falls drop by drop. What will happen if high voltage here is applied to the needle in this state? Electrical repulsion will occur among the water molecules. As a result, from the tip of the needle, millions of highly charged small droplets of water are sprayed out by pushing each other. This is electrostatic spraying motion.
I see, that's amazing. So how can this electrostatic spray help improve indoor air quality?
I said earlier, the surface of water droplets sprayed by electrospray are highly charged with many of electrons. The sprayed water droplet attract the fine particulate matters around them through electrostatic attraction, which is how we agglomerate and also remove the particulate matters.
Interesting. But some air purifiers already use water. How is this different?
Good questions. Traditional air purification technology using water simply heat directly fine particulate matters with that water to remove the particulate matter. This new air purification technology using electrostatic spraying is much more efficient than that, as it uses not only direct collisions but also indirect collision caused by electrostatic attraction. As you know, the subway station is a semi-enclosed space, so there must be more pollutants within it than outside. There are two main components of fine particulate matter in subway station, which are carbon-based particles from outside and iron oxide-based particles generated inside. In addition to the fine particulate matter introduced from outside, the ultrafine ion particles generate from wear and tear of running train wheels and railroad tracks form nearly half. We have developed a particle collection technologies that is customized to that characteristics of each type of fine particular matter. In consideration of this environment peculiar to subway station. For example, when we use electrostatic spraying to bind such a small particle, we must not bind iron particles with water, because if we do, the particles can become collide and pollute the water that will be recycled and reused. So we install a copper coil at the purifier air intake to generate an induced electromagnetic field to collect ion particles first and then bind the other carbon-based particles with the electrostatic spray here.
I would say that your hard work has borne fruit. The result of the testing inside a subway station was an astonishing 98% reduction in PM 2.5, which is fine particulate matter.
Right. We operate two electrostatic spray air purifier, each with a capacity of 30 cubic meter per minute for an extended period of time, resulting in up to 40% reduction in fine particulate concentration in area of approximately 264 square meters. Moreover, hydrogen peroxide and ozonic water generated during electrostatic spraying have a sterilizing effect. This result shows that it reduced 99.9% or more of total airborne bacteria and 96% or more of total VOCs. Since this device has no air filter inside, actually we don't have to replace air filter periodically. Also, power consumption is very low due to the small pressure drop. Replenishing the water and periodically changing much cheaper water filter, that's all we can do for its maintenance. In fact, installing all of dust collection, sterilization, and TVOC oxidation equipment to manage indoor air quality in semi-enclosed space such as subway station and underground shopping malls can be a huge burden on consumers, considering the installation cost, maintenance cost, and space constraints. Our water-based 3-in-1 electrostatic spray technology is an ideal solution to this. We have just finished verification of the basic performance test of the electrostatic spray air purification technology, and we are also planning to test it on a variety of other odors and viruses for commercialization.
Kier is planning to further develop and advance the electrostatic spray type air purifier so that it can be widely used in multi-use facilities around the world. Since the air purifier does not use HEPA filters, it is expected to cause less pressure loss and lower differential pressure, resulting in relatively less noise even at the same flow rate, as well as reducing operating costs. In addition, as the water used for collecting particles is completely recycled, less water is wasted and no treatment costs are incurred. The electrostatic spray type air purification technology can be used in a variety of multi-use places, such as subway stations, daycare centers, schools, hospitals, department stores, military bases, and religious facilities. It is expected to both contribute greatly to economical and effective improvement of air quality and take the lead in improving the air in urban infrastructure. We hope this technology will prove useful in more countries to help people around the world live healthier lives.